Okay, this is the teacher station for sketching polynomials. I want you to pause the video for a moment and get your notebook set up. You can see we've got page 91 and then your two little papers go on the left side page. We will also have that problem on the bottom there, this one. We won't do this today, but I want you to leave the space for it when we do it on a different day. Also notice I did write a couple of things. I want you to write those as well. So pause the video now, resume when you have all of that ready. Okay, we talked yesterday on Monday about a bunch of different stuff relating to the polynomials, and I have that summarized here. The three most important things are where are the roots? We get those from the factors using the zero product property. What happens at the root, which we call the multiplicity, which can be 1, 2, or 3, and what is the end behavior. So let's talk about the multiplicity again, just real quick. If we have our x-axis, and we have an x-intercept. If it has a multiplicity of 1, that means the exponent. I'm writing on the iPad. I'm not very good at it, so you do a better job. Okay, so if the exponent is 1, that's the multiplicity of 1. That goes straight through. Okay, if we have a root here and we have a multiplicity of 2, that bounces. So it hits the point and bounces right back off. And a multiplicity of 3, we've got our point, and that is going to look like a cubic. So it's got that inflection point there, or the wiggle. Okay, and then we have our end behavior. The end behavior can be kind of difficult. We talked about this first part, the leading coefficient. Okay, the leading coefficient tells us the end. The lead tells us the end. That is counterintuitive. We would really love the leading coefficient to tell us the beginning. It does not. So we really want to make sure we know that that is opposite. So if it's positive, it ends up. Negative, it ends down. That makes sense. And then the thing we didn't talk about, we talked about how to find the degree yesterday, but we didn't talk about what it meant yet. The degree tells us how it starts. Okay, so the leading coefficient tells us the end. The degree tells us the start. And that is, if it's an even degree, 2, 4, 6, then it's going to start the same as it ended. And if it's odd, 1, 3, 5, 7, etc., then it starts opposite of how it ends. So very counterintuitive. We're starting with the end of the graph, and then we're going to the beginning. All right, let's see how this works on one of our examples. So we have this first one. We want the roots first. They could also ask you x-intercepts here. Remember, those are the same thing. They would just be written as a point. So our roots, we've got right here. This gives us a root of 1. So you can see on my graph, I'm going to make that dot at 1. This gives us a root of negative 2. And this one gives us a root of 4. And that's pretty normal for what we've done before using that zero product property. So now what happens at the roots? So this one in pink here, 1, has an exponent up here of 1. It's not written there, but we do have to have an exponent. So that is going to go straight through. At our red x-intercept at negative 2, that has a squared, so that is going to bounce. And at our blue root, we have a cubic, so that is going to make a little inflection point. Okay, so we know what happens at our roots now. Now we are going to look at our leading coefficient. Our leading coefficient, LC, is 2, which means we are ending up. So over here on the end of my graph, you're going to see I'm going to draw an arrow that's ending up. At some point making my graph, I need to connect with that arrow. And the last thing, this is kind of our newer thing, we didn't talk about this as much yesterday, is the degree. So we did learn how to get the degree. Okay, the degree is all of our exponents added up. So 1 plus 2 plus 3, we get a degree of 6. We do not care as much that it's 6 in that it's even. We care if it's even or odd. So we have even, which means that it's going to start and end the same. The same as what? Well, we already have the ending. So we had to start at the end. Again, weird, I know. We're starting at the end. But then if we're going to have the same, then that means it also has to start up. So I've got that arrow there. All right, now I'm going to switch to black. We've got all our colors here that show us all the different things. And now we're going to use the black one to actually fill this in. So I have to start somewhere. Where do I start? Well, I've got my purple starting point. Okay, now I'm moving towards my first x-intercept. And then I look at that x-intercept and I've got to go over here and say, okay, I know at that red point that it's going to bounce. So here I go. I'm going to go down to the red point. I can't go through it. I'm going to bounce right off of it. Now, you don't want to go too far past. You don't want to bounce off and do this because now I missed the rest of my stuff here. So I bounce off just a little bit. Now, the next thing I have to do is go through that pink x-intercept, which means I'm going to have to turn around. So it doesn't matter. You can make it there. You could go higher. You could go lower. That's up to you. This is just a sketch. So yours might look slightly different than your neighbor's. It doesn't matter. As long as yours bounced at the red, that's what's important first. Now at my pink x-intercept, I notice that I'm going straight through. So I'm going to come down here and I'm just going to go straight through. Now I have to turn around because I'm going to go back to that blue. My blue x-intercept, I have the cubic. So as I go through there, I'm going to make my little squiggle. And look, I am meeting up with the ending, which I knew I had. If for some reason I had done this blue one, let's say I had accidentally bounced there, I would have had that clue at the end because I would not have met up with my green arrow. So that kind of gives you a clue that you missed something. So there we go. That's our first sketch. All right, I'm going to look at my next one. So first we're going to start with our intercepts. All right, we've got a -1. These are our roots or our x-intercepts. You can say either way. So we've got -1. And our next one is at 3. And then a lot of times, this is the one that's missed the most, is we do have another intercept here. Every x gives an intercept. So we do have this x right here. Okay, it's plain, which means it doesn't have something added or subtracted, but it secretly does. This is really an x plus 0 squared. So that gives us a root at 0, that plain x. Now, this 4 did not make an intercept. That 4 is just the leading coefficient. All right, so we've got our intercepts. Now we should say what happens at all of them. So I'm going to go look at my pink one. That is a 1 right there, so that's going to go straight through. My red intercept here at 3, that is also a 1, so that's going to go straight through. And my last one at 0 is squared, so that means I'm going to bounce at 0. Okay, now I need the leading coefficient so that I can get the end of my graph. My leading coefficient is -4. I don't really care that it's 4, I just care that it's negative. So this graph is going to end downward. Okay, and then the last thing, I want my degree. So I'm going to add up my exponents. 2 plus 1 plus 1 is 4. That is even, which means it's going to be the same. Same as what? Well, what I already have is that it's down. So if I'm going to be the same, it also has to start down. This is the start, this is the end. All right, time to graph. So I'm at my starting. I'm approaching, the first one is the pink one, and I look over at my work and I see, okay, that had an exponent of 1 here, and so I'm going to go straight through that. Now I have to be really careful there because that blue intercept is very close, so I barely went past there to go straight through. And then my blue, I have a bounce. So I'm going to turn around to go to my blue, but I'm going to bounce right back off of it. Okay, I move up. I'm going to have to turn around to go to my red one. And my red one, I'm going to go straight through. Now, am I going to meet up? Perfect. I'm meeting up with my arrow. Notice I didn't do weird things like that. We don't want to do that. We need to kind of have smooth curves. So it's fine. We put that green arrow there as a marking just so we know we'd meet up with it. It doesn't mean you have to go right there. Another thing is some people will call this part a bounce. That is not a bounce. Bounces happen only on the x-axis. So I bounced off of the axis. This is a turn. This is a turn. We always turn around between every root in order to get to the next root. So if we have roots, we go through one, we turn. We go through one, we turn. We have another one, we turn. Let's say that bounce there, we would still turn. So make sure you know the difference between a bounce and when we're just turning around. All right, I want you to go ahead and move on to this example. I want you to pause the video and I want you to try getting the information and sketching on your own. Make sure you're using a pencil here. That way you can change it if you did not get it correct. So again, please pause the video and try on your own. Okay, hopefully you have some of this information. I've got my roots here, 3 and -2, and I have their behavior. We have a cubic and a bounce. Ends up, and you'll notice my degree. This is the first time we've had an odd degree. So that means I already had my ending of up. So if I'm going to be opposite, that means I have to start downward. So the green and the purple are opposites here because the degree is odd. All right, so I'm starting here. I'm approaching my red root. I look and I see I have to bounce off of that. So I get to the red and I bounce off. Okay, now I have to turn around. That's not a bounce, it's just a turn. And I'm approaching my pink root, and so I need to make a cubic there. And am I going to meet up with my green arrow? I am, so that means I did it right. Or at least it's a good chance I did it right. Okay, and our last one for today. We want to write a reasonable equation for this, this graph here. So first of all, make sure if we're writing an equation, we are writing f of x. Now think back of what we did in our previous one. We needed to take the equation and we got the roots from it. And so we're going to do this the opposite here. We're going to say, okay, I'm going to look at the roots that I have. I've got a root here. And I've got a root here. And I have a root right here. Are there any other place it's crossing? No. Then those are all the factors that I need. So I am going to leave a little bit of space at the front because we'll deal with if we have a leading coefficient or whatever later. So the first one I'm going to do, that pink root is at -1, so that means I need a factor of x plus 1. Okay, and then I look at that root, and what does it look like there? That looks like a little parabola, so that means I need a squared on that one. Okay, I move on to my next root, which is the red root. It's at 2, so my factor is going to be x minus 2. And I look and I see what is happening there, and that has that little squiggle cubic. So in my equation, I'm going to have a 3. And my blue root is at 4, so that means I'm going to have x minus 4. And I look at the equation there, and I see that's just going straight through. So that has an exponent of 1 here, although we do not write that. Okay, again, exponent of 1. But we don't write it. For a moment, I'm going to write it there. I want you to look at the degree here of all of these. 2, 3, and 1. Actually, let me get a different color there. 2, 3, and 1 is 6, which is even. Does this graph start and end the same? Yes, they are both down. So that is just a confirmation that we do have our equations set up in a nice way. All right, so I'm going to go backwards. I'm going to erase a little bit because we don't really want all of that on our equation. We want it to look really nice. So we don't want that blue 1 there. Okay, and then the other thing is the leading coefficient. So the leading coefficient tells us how the graph ends. The graph ends down, so that means I need to have a negative number there. Now this asks for a reasonable equation, not an exact equation. So it doesn't really matter. I can kind of make up something that I think is reasonable. As long as it's negative, that's good. And we don't want to be ridiculous. We're not going to say like -1,000 here because that would make like much bigger hills than we have. So -1, -2 are good. I'm just going to put a negative, which really means I have a -1, but I'm not going to write the 1 there. If you feel like, oh, I don't like that negative out there, then go ahead and make a -2. That's okay as well. Okay, but it does need to have some sort of negative out front. And that is a reasonable equation for that graph. Okay, that's all we have right now. So make sure, hopefully you pause the video and we're able to get everything copied down. Go back and re-watch anything that you need.